throughout the lobby. I will check back in and out here, but I wanted to just have turn everything over to Jeannie. Jeannie's got some interesting data that she's going to go over based upon using materials, finding out the material values with limited information. So with that side, Jeannie, go ahead and take over, and I'll let everyone in the room as they come into the lobby.
Okay, I'm going to go over how to process the material data you have. Most time you have only limited data. So I took 2 examples. This is the first one. That's their certification come with the shipment. So the first glance, they have chemical compound, which is useless for us. But if you look very carefully, right here, there's 3 data here relative to us. The yield, tensile, and elongation. Elongation doesn't have any unit, so we know that's 8.9%. The other 2, they didn't even give the units, so you have to guess. This one, they have pounds here, so I would think it's an English system, so probably it's a PSI, so that's a guess. So for PSI, we need to convert to KSI. Oh, I think I made a mistake. 1,000, yeah. So PSI to KSI, then we convert to megapascal because we use the matrix system. Megapascal will be our stress. So the yield from here is this number divided by 1,000. Then, is that right? Yeah, 1,000, and then multiply 6.89 to convert it to megapascal. So the yield is 817, pretty high yield. And then tensile, we do the same conversion, we get a megapascal. Now we have to work with this elongation. If you go to this, if you go to Ansys Forming and go to material, when you get this data, you can start a new material. We can do that. Start a new material here. Default, you will have all the default steel properties here. Then right here is the number we need to figure out. So we don't have the curve. We can use this first 2 formula to create our own curve. So what we need is this the yield stress, and this is the K value and N value. So we need to figure out K and N. So how do we do that from the information we have here? The elongation, 8.9. So I'm going to go to the next page. 8.9%. So elongation 8.9%, which same as 0.089. So you can think this percent is divided by 100. So that's 0.089 actual number. Then the N value, the formula for N value is log plus 1 plus 0.089. So you just need to go to your calculator, put 1.089 and hit this line. And that's your N value. Yeah, this material has a very small N value. And then now we have N value already, right? Remember, we need the N value. We also need the K value. This is a yield. We have that already. And then this is just the number with or we need is the x-axis number. That's the y. So we need a K value. We got N, we need a K. Good, so far so good. So the formula for K is this. So the tensile stress, I should write the whole sentence. But the tensile stress is equal to K N to the N. So the K value is tensile, so we reshuffle this formulation, divide both sides by N to the N. We got K value equal to tensile stress divided by N to the N. So, and what you can do is we go back to the calculator. Yeah, the simple calculator, we can just get this first. So 0.089 and then 2 exponential to the 0.089, and that gives us 0.0806. That's this portion. So we need to flip it because it's on the bottom. So you flip it and then multiply by the tensile stress. So the tensile stress, in this case, we're going to go back. The tensile stress we got is 106106. So multiply 1061.
Hello.
Hi. Oh, I think I made it mess up. So what did I do? Okay, let's restart. So 0.0, the n value is 0.089, right? Let me go back. So our n value is 0.089, and our tensile is 106106. So pull up your calculator, and then 0.089 to the 0.089 and equal, flip, multiply 1061.06, and that's your K value. So 13, 15, pretty much 1316. So your K value is 1316. Okay, this is actually the unit of stress. Then you can just go back to your ANSYS forming, put this 15, 16, right? And the n value is 0.089, and the yield is, can't remember anything today. Yield is 817. So 817 here, and that's your curve. I'm putting your n value here, and put your, normally when you have the model, you have the blank thickness here. That's how you get all your material information with this limited information. It's not precise, but it's pretty close, okay? It's not exactly right, exactly accurate, but very close when we have a lot of success with that. So one more thing I like to talk about is we always say engineering and true, engineering strain stress and true strain stress. What's the difference? And when we convert the n value, when we calculate n value, we actually convert n value from engineering to true. This is the engineering to true. They're close, but they're not the same. The difference is the engineering strain and stress, let's say engineering stress, is force over the original cross-section area. Okay, so the force, as the force change, the cross-section stay the same. It's the original cross-section area. And the engineering strain is the change of the length over the original length. That's engineering. If you look at the engineering curve, is this red curve. Because when the material become weak, we still divide by the original area. So the curve kind of low, become lower. And the true stress and strain, using the true stress is force over the actual cross-section area of your material. So this A0 is not the initial cross-section area, it's the actual area. That's the reason if you look at the true engineering strain, stress is higher than the true strain stress is higher than the engineering strain stress because it divided by the actual cross-section at that moment. When your material become weak, thinner, when the force increases, your cross-section becomes smaller. Your stress is divided by an actual smallest area, so the number is higher. So that's how you recognize the true and the engineer. Engineer flats out and goes down. True goes continue out till it break. That's engineering true. The curve we have is normally direct we call the yield curve. okay, or hardening curve. So we have 3 curves actually: engineering strain stress curve, true strain stress curve, the blue one, and the hardening curve. Hardening curve is very similar to the true strain stress, except it shifts a little bit, shift to the left. See that? That's because if you think your stress as strain and stress and total strain stress, there are 2 portions in it, the plastic portion and the elastic portion. So the hardening curve take off the elastic portion. Okay, so hardening curve you can also call the plastic strain. It's a total strain minus the elastic part. Okay, elastic part we know it's a stress divided by Young's modulus. So that's how the engineering and true calculation always use not true strain stress and then further on the hardening curve. We never use the engineering strain stress. So that's the first topic I like to talk. This is the example too. So when you see this certification, you know it's hard to see you find any information useful, but you do if you look carefully. You have elongation here, 7%, and then you have the UT we call alternate tensile stress, and also the yield stress, and then they even give you the units KSI here. So you can work with this. Always use the minimum. Try start with your minimum number, worst scenario. So for this, we know we need to take the log 1.07 to get the n value. And then we convert these 2 numbers to megapascal from KSI, and you have the formulation in here. So we all have all the formulation here. And then calculate the K value. Then go to your ANSYS forming to enter those values. Okay, so one more thing I like to talk is always examine the test data. If you send your material to test lab to test, you always check the curve. This is garbage. If you look at this curve, it goes up and jumped like that. First, I don't like this slope. The beginning slope is not this smooth, normally sharper. What they did is we actually traced down, have the customer talk to a lab guy. They said they changed the speed right here. Well, change speed, they would try to save time. If you compare 2 materials, you can do that. You know, both materials change speed there, both materials jump there. But for us, this messed up everything. And if you have this, send it back to the lab, have them redo it, tell them you cannot accept this. So that's all I like to say today. If you like to see other material, this is the Ludwig. So we have the initial yield and K value, N value, we got everything. The next one, Swift. Swift just needs the K value and N value, and this is the initial strain at yield. This number normally very small, normally like 0.2%, so it's 0.002. You can ignore it. You can ignore this, just give the K value, N value here and put a 0 here. Actually, when you put a 0 here, unless it's a very, very strange material, yield very late, it close enough. So that's the material information I like to, how to process material information I like to tell you. If you like to go more precise, I do have a PowerPoint show you how to process data. If your lab gave you all the curves, you know, these are the standard material process. This is from Crash people. They normally give the test example with the standard, we call dog dimensions with the different standard. This is the mini pencil. This is ASTM standard tensile test. This is also another tensile test. It's ASTM E8. And I have one more attachment. This is regularization. This is for Crash people. Then you will have the curve from them. Yeah, this mentioned the yield curve is This is engineering. They normally give you the curve of engineering strain stress. And then what we need to do is convert them. This is the same slide I showed you earlier. Convert them. This just explained why we need to convert it. Okay, how we get that log. The conversion between engineering and true is this. Engineering, true stress equal to engineering multiply 1 plus engineering strain. And similar thing for that. So that's the formula we calculate the N. N is a strain. And then from there, you have to do the shifting, which is converted to plastic strain. And then you have to, yeah, this is just the Dyna card. You have to smooth curve. Some curve is smoothable, like this one. We can smooth them into this green curve. The red curve is the original curve, and then we smooth them, make them the green curve. Then you get your yield curve, which is the curve we need. Getting the curve, accurate curve, is the crucial part of to get a good simulation. But our case, we use the formula also works. So I'm going to put this PowerPoint there too. You can go over them. It's a little bit overkill. The way I showed you here should be very close already. And this PowerPoint will be on the FTP side also. So I think these are all handy conversions, especially this formula. You will use them a lot to get the K value, this one. And you probably will use a lot of conversions. For unit system, we always need to use millimeter for length, second for time, and ton for mass. That's the 3 basic one. With these 3 basic one, the force will be derived as Newton, and stress will be megapascal. Ansys Forming right now only support this system, which is millimeter second ton. Good. Any questions? Joe, can you hear me?
Hey, Jeannie, I got a question.
Yes.
For the, I think it was the Ludwig hardening formula.
This one?
Yeah.
Yeah.
Yeah. So
Yeah.
that first entry there, the 817, is that true stress, or is it is it true stress at 0 plastic strain?
It should be true. Yeah.
Okay. So that formula that you were using to convert it, was that changing from engineering stress to true stress, or doesn't it make that change?
Let me see.
Or is it that close that it doesn't really matter?
Yeah, for yield, the strain, this one is very small. It's 0.002. So you're right, theoretical, I should do this. I should multiply that stress by pretty much 1.002. So almost the same. Yeah, I just ignored it.
Okay.
Yeah, thank you for that.
Good points. Anyone else? Jeannie, is there anything you want to go through as far as on the software?
On software, I was back if there are any questions. Lately,
Yeah,
I didn't get too many support. Everybody seems happy. The only thing is some people forgot on the post process where to turn on the thickness, which is right here. It's a little bit hidden. Goes here and then right here. So it's in this little suitcase, and then turn on blank tool position check. Yeah, the reason they call it that is because originally was designed to have people check the tool position for invisible offset, for tool offset. So for tool offset, the tool normally you couldn't see where they are at. The contact offset. The contact offset, you have both tools in the same location. When you use this function, program will automatically offset for you. But most people like to see the actual thickness of there. And you can tell in this simulation, your mesh is too big. See it cut across the corner? So you need to cut more, mesh size need to be smaller to avoid this. And others support mostly on material, how to get their own material. That's about it. Yeah. The other thing is lots of you probably don't need this, but if you have simulation failed, okay, error termination and then didn't run through, the first thing you should do is go back from post, go back to pre, from post back to pre, and back to that operation you failed. In my case, I only have one, and you come here, and you change this output interval. This is the output interval. Default is every 5 millimeter you have a frame DC plot file. Change them to 1. Okay. This way you can see where it starts to go crazy and failed. And then you check from there. Most times, probably your tool has some issues. If that's the case, you turn on that tool. In this case, I'm going to turn on the die. Come here and right click and say mesh check. Check the mesh. Okay, see this, in my case, I have a lot of tiny elements here. And you can repair them. You can just say, oh, the tiny element, sometimes if it's not too tiny, it doesn't matter, just a little bit. I'm going to turn on the mesh. You can see it's just a little gap there. Sometimes it's fatal, sometimes you can get away. If it's fatal, then you can say all, repair them. Right here, repair selected or repair them all. And program will automatically repair them. After repair, sometimes you might have new issues. Let's see, it have more gaps now. So you can click here and then click on this eye. When you click on the eye, it will show you where exactly. You don't have to look for them. Okay, you can tell, oh, there's some small gaps there, should be okay. Or you can say, I like to repair this. You can say repair selected, so to automatically repair them for you. For us, for formability analysis, mesh don't have to be perfect as long as you don't missing the whole chunk and then the blank run away from that gap, you should be okay. But for compensation, you need a very good tool mesh. Connect them. You shouldn't have anything listed here to compensate your tool. Okay. So that's just mesh repair. I think I will, as the compensation module released, I'm going to go over more on the mesh repair. Okay, for now, just keep in mind if your job crashed or didn't finish, something wrong, go to here and then write out more DC plot file. This means every 1 millimeter will write out DC plot file, and the next one, this means before the home position, 1 mil, 2, 3, 4 mil, 5 mil, we will have additional DC plot come out. Okay, this is default. You can also change that. You said, okay, I need more, maybe 6 mil from home, maybe more, 7 mil from home. You can add as many as you like. Good. Any questions?
Actually, we could even go off topic. We have plenty of time. Otherwise, we can just also cut this short and have everyone resume to their lunch. Any other questions we can answer for you?
I think that for our group, Joe and Jeannie, by the way, thank you for inviting us. I think for our group, just getting into this, Neil and Kurt may have just a couple of questions regarding trim line for trim development. And then Kurt and Neil, what were the other questions you had about whether or not the software could support us? Can you kind of reflect on the questions you brought to me? It's a good opportunity for us to get their direct feedback.
Well, I think originally one of our main questions was about the material library, and that's what she started with is how to get some of that information for ourselves by what's given to us from the supplier.
Mhm.
But Jeannie, the library is now much more broad than what we initially saw, correct? It just wasn't fully loaded when we looked at it earlier. Is that correct?
We have quite a lot of material library, but you can also import all your existing software material library here.
Okay.
We do have a procedure to do that. I actually upload that into the FTP site for the user group. I do have some customer already successfully import all their existing material library right here. So
Wonderful.
You can pick.
Okay.
We're constantly adding more material here. It's quite a lot of material now.
Okay.
But you can import your own.
Okay.
I'll send you the information where to download them. It's where you download the software. There's a folder called I forgot the name. Let me see. I think it's under Ansys Forming document, how to hook user-defined material, right here.
Okay.
Yeah, this is just a general PowerPoint. And today I'm going to upload this PowerPoint, the one shows how to calculate the K value and value here.
Thank you.
Thank you, Karen.
And then one of the things, just because of a recent exercise we had to do for a customer, is we're developing, it's going to be a developed blank. So we really need the trim edge to be their final trim edge. And so we're just wondering about the accuracy or the strength of the software to accurately track those trim edges on a custom blank.
Okay, I'll show you this is a trimline example. For trimline operation, I'm going to show you this is the tool, the upper tool and lower tool. That's the initial blank. And this is the target shape.
Okay.
I used to have the product card. That's the product. So for the product, it's a solid surface. We need the center. See this one? The simulation is in the center. So we need this center line. So that's the target line for us. So what you do is you when you go to setup in the process operation, you have the draw. You need to add a station called blanking. Blanking is actually just trim, just a trim operation. So if you go to operation, you will see a trim operation, which is the initial guessed trim shape. And then this just set up the draw. Set up the draw, you have die, one die above, this is single action. And then punch on the bottom, you will see the binder punch all in home position. It's all start from home position. Then you go to advance. Oh, sorry, I'm going to go back one more stage. Right here in the first process, you need to select advance. Tell the program this is trimline development, not the regular forming. When you come here, it's going to tell you need a blanking operation, stuff like that. Then after setting up the operation, you run the job. Oh no, not yet. You have to set up the target line. You go to advance. This is the manual for trimline development. Our case, we only have one curve. You can have several curves. We only have one target curve. See that? You define a target curve, and then you say, I need to develop this curve. Default was not developing. And then you say, develop this, and the target, select the target curve. When you first come here, when you first come here, you only have this trim line from the blanking operation. Then you see give the trim target curve. That's a tolerance. This is how many iterations. Then you run. After run, after finish, you go view result. This is already a run. It will show you initial run. You have point weighting tolerance only 26%. So the red color shows it's off the tolerance. Green and blue said it's within tolerance. Blue means it's a little bit too large. Green is a little bit too large. Blue is a little bit too short. So that's iteration one. That's the initial iteration. And then iteration one, the next iteration, you got 93% match. So 93%. Then you can just, I'm not sure I run the iteration two. Yeah, once the 93, I stopped. So there's no result for iteration two. You can continue. If you have time, you can continue, make it near 100. Then you can export them, show the trim line. See, that's the correct trim line, meet the target. The blue one is the initial guess one. And you can export them. Export, and that's your trim line. Select the folder, it will write out as a trim line edges. So we have several, quite a lot of customers use the trim line. So far, Joe, you got any article about trim line or?
Oh yeah. I mean, as far as the information, as far as the sales information, we also do have a video on YouTube that I can direct everyone to and send that to them to get a little bit more experience on seeing the development of of you solving for that trim line on the internet, as well as doing it with your own part. I can send an example. I think that's the best thing to do.
Karen was asking if any feedback. I remember one of the two shops said it was very accurate. They used that trim line. It was very successful. I think it was William tool. William?
I think so.
Yeah. Yeah,
We appreciate that.
I believe, I also believe Jim is on the line. Jim Bristle, is he on the line today? Because he uses that strongly, if I'm not mistaken. No, he's not here. Okay. Yeah, KT uses that quite often.
Yeah. Karen, I forgot if I showed you guys that we have several examples on trim line. Right here. This just shows the trim line methodology, initial blanking, and then blanking operation, draw, compare, converge, no, come back. And there are lots of examples. I think this is from William tool. That's a very tough one. 2 iterations, they converged. And
Well, Jeannie, go ahead.
Go ahead. Yeah, and
No,
you separated. Yeah, go ahead.
I just was thinking if we could get a copy of this presentation, that would be wonderful. I think it would be a great tool for our team.
Sure, I think this is the one on the FTP side. Remember two files there. One is this. The other one is how to plug in the user-defined material. Yeah, so this is also another example. It's an electronic part. This guy tried to match the trim line outside and inside also. That's the initial comparison, iteration 1, iteration 2. This one more, that's the developed part also. initial iteration, second iteration. See, that's only one curve. And this, I want to show you. This one, he separated into several curves because he doesn't want to develop this area. That's the carrier area, I guess. So he split the curve, then only develop those areas. You can see a lot of curves here. And I think we have more example. This is, they try to develop this trim hole right here. This is a double attach, developed initial run, iteration 1, iteration 2. So once it's green and blue, it pretty much matched with the tolerance. You can change the tolerance, make it tighter. It's one more. Trim line, initial and then final. Yeah, this is the exact PowerPoint for the ANSYS overall.
Yeah, I can put a
Karen,
link to that FTP site. Karen, if you don't have the username and password, I can send that to you along so you can grab that as well and see what else is in there in the file.
I'd really appreciate that. Thank you.
Yeah.
I know our team could benefit from it.
Yeah, I think we can send, did we send all the download information to Karen, Joe?
Yeah. No, I have not. Is it now appropriate time to send the download information? We're talking for trials?
Yeah.
Okay, yeah, we could discuss that outside of here. Yeah, no problem. I can send that link and get her set up.
Anything else you'd like to see, Karen? Karen?
I think we're good. So yeah, if that could be sent over, that would be great.
Yeah, okay. Yeah, I think we can have your group download them, try them. I have a lot of customers, they can download, install the trial license and then start using it very quickly.
Yeah, that would be fantastic.
That's great.
Yeah, I'll get that out. Is there any other questions we can address? So it looks like we have 15, 20 minutes still left in the clock.
Yeah. Jim from Digeco, I got the information from your IT guy about the FTP uploading. I assume that the IT person couldn't access the FTP. I'm going to upload the file for you, if that's the case. I think Jim is muted.
Okay. Yeah, he might have stepped away, but
I'm here.
nevertheless, oh, good.
Sorry, my mic is muted. Yeah, I didn't catch what you said there, Jeannie, about the
Yeah, I got an email from your IT person about the instruction of how to upload file to your FTP site.
Yeah, because we have a problem with using the other FTP site with our security
Okay.
system. That's all.
Okay.
Yeah, that was in reference towards the newest version, the 9.18 version you talked to me about the other day.
Okay. So he couldn't go. Okay, I'll upload the new version for you.
Yeah, I think I don't know if you mentioned on there's like a 3-day security window where you can use that password and then expires.
Oh, okay. Okay, I got it. So they are new versions on the FTP side. The new version sometimes not as stable, but we're adding new functions. For example, the mesh repair is adding new functions there, and also we support blank with surface now. So when you define blank right now is curve or mesh, not surface. We add that already. But somehow I tested it's only for one surface, Jim. It's not for multiple surfaces, so I just send them back that they need to do multiple surfaces. Just to let you know that.
Okay.
I think they also fix some bugs for IGES import. Right now, that file import is very stable. IGES file import sometimes a little bit, there's some hiccups. They're still fixing that. Other than that, the newer version also adds some features on when you first import your geometry. You need to delete a lot of surface sometimes. So the new version have a delete function. Let me show you. I think I have it here. So if you go to pre-process, right here, they add a delete feature. So right here, you can delete surface, curve, points. Yeah, the reason we do that is sometimes, let me see if I can find them. Sometimes they have surface, way too many surface, like the lower tool, lower punch, they have all the nitrogen cylinders and also all the screws and dowels, and those really slow down the simulation. So you very often you have to end up clean the surface. Just simply delete them. So you go here, delete is a new function added, and that's what I can think of. Post process, I don't think they changed anything. Nothing changed. Next time I'll list all the. I will try track all the improvement, all the new information they add in.
That could be a topic for next month.
Yeah. Okay. And also we do have this contact. Yeah. Remember you have this contact information. Other third-party software, they normally don't have that because this require turn on certain parameters to calculate the contact information. It's a different set of the file actually. So in contact information, you can check the gaps between your blank and the tool. Also check the contact pressure to see where your tool might handle a lot of stress, which means it will wear off right here. So, and force. And one more thing I think I'll talk about this next time is when you set up draw analysis for the binder. For the binder, you always have this force option here. And you can give a constant force, or you can give we're trying to, or you can give a curve, so that this is not a constant force, it's a curve from zero, no force, to the cushion. Let's see, cushion travel is 200 millimeter, and then the final force was 400 solid. Can give a curve. So this is all the new function to simulate the nitrogen cylinder. And you can see this binder is, click on this binder part, and you can see this binder is connected to the punch. It's attached to a punch. What they do is, when you do that, when you say the binder is connected to the punch, what they're doing behind the scene, they put a spring between the binder and the punch and simulate the nitrogen cylinder effect, which is right here. See that you have the force and the cushion length actually is the travel of the binder. In this case, it's the upper binder and the die. Upper binder connect to the die. So this gives you a more accurate on the force, on the force simulating the nitrogen cylinder, and also make the setup very easy. See this part? You have the upper die, lower die, and you have lower binder, upper binder, and then a center pad, lower pad. This can set up with only one phase. The previous other software, you probably need 3-4 process to measure how much this traveled, and then how much further travel here, and then how much travel here. At least 3 steps. This only one. So die travel all the way to home. Upper binder driven by die. So upper binder is pushed by die with the force information provided under. And then the lower binder also driven by die, inner pad driven by die, punch fixed, and force information is all here. And cushion travel, cushion lines can be provided too. So I think next month I'll talk about this function in detail. Joe, can you check if Chad is here? Chad from Best Tech tool?
No,
Oh,
no.
yeah.
I'm just sending off this PowerPoint presentation in PDF format over to Karen. And I believe I sent also the way to get into the FTP site. If anyone else needs that, please let me know. I'll attach your name to the email.
Yeah. So this function will make the force prediction much more accurate and also make the setup much easier. Yeah. If you see your previous people using software keep tracking those distance and then how much, you don't have to do that. With this, you just select which part is the dominant tool, which one is the passive. For this case, the upper binder will be passive, pushed by die with those informations. And this driven by die function is very new. I mean, not new for Ansys Forming, but pretty new for the previous software. They don't have that. Okay. Good, Joe. I don't have anything else anymore.
No, I think we're good. If everyone else is okay or doesn't have any questions, I think we'll wrap things up and give you back your last 10 minutes of your lunch. And I do again thank you for attending. If there's any questions, please feel free to contact us. Next month, we will work on an agenda to make sure that we have some informational contents that we can go over with Jeannie again. So if there's any questions or anything that you would like to see, please send those and address those to me, and I can get those over to Jeannie, or just send them directly to Jeannie, and we'll use that contents for those who have questions. But thanks again, everybody, and take care and have a good rest of the day.
Well, thank you guys.
Take care. Bye.
Thank you. Bye now.
Thanks so much.
Thanks, everybody.
Bye-bye.
Bye, everyone.
Thank you. Take care, Karen.